Hi, welcome back to Math's Playground. Now, today we're going to be working on some exponents, just in case you got confused on the previous video of logarithms. So, let's start with a question. What is an exponent and why do we need it? Well, first let's start with how you read or write exponents. So if you have a base of 2, the exponent part would be, if you did a tiny little 2 up here, this one would be the exponent. We can read this whole thing as 2 to the power of 2, 2 to the second power, or 2 squared. And if we want to solve this, it would be 2 times 2, which is equal to 4. And see how we use this? 4 is much bigger than 2. So we use this so that we can write bigger numbers in this tiny way. So if we wanted to do 2 to the power of 3, we could read this as 2 to the power of 3, 2 cubed, or 2 to the third power. And now this would be 2 times 2 times 2, which is equal to 8. Then we can also do it with 3 to the second power. We would have 3 times 3, which is 9. You can write any huge number with this little thing. If you wanted to write 1,000,000, obviously you wouldn't want to write all the digits. You could just say it's 100 to the power whatever, or 10 to the power whatever, and just stick with that. Exponents are used to make bigger numbers into smaller ones. So you could try to memorize some squares if you want. It comes in use sometimes. So 1 to the second power would be 1 times 1, which is equal to 1. And then 2 to the power 2 would be 4. Then 3 to the power 2 would be 9. 4 to the power 2 would be 16. And then 5 to the power 2 would be 25. 6 to the power 2 would be 36. 7 to the power 2 would be 49. 8 to the power 2 would be 64. 9 to the power 2 would be 81. And 10 to the power 2 would be 100. These can come in use, but don't just memorize them for no reason at all. It's just a waste of time. But they can come in use one time or the other. And we also have a few exponent laws when a is non-zero. A to the power b times a to the power c is equal to a to the power b plus c. And a to the power b, a to the power b, the whole thing to the power c, is equal to a to the power bc. And then a to the power b divided by a to the power c is equal to a to the power b minus c. And then a to the power negative b is 1 by a to the power b. A to the power 0 is equal to 1. And ab to the power b, this whole thing to the power b, is equal to a to the power b times b to the power b. And then we have a to the power 1 by 2 is square root of a, which is super interesting. And then And then it's like a to the power 1 over 3 would be the cube root of a. And you know how if we do to the power 2, it's called you make it the square of a number? The square root of a number would be taking this away and what we're left with. So the square root of 4 would be 2. The square root of 9 would be 3. See how we're just taking these 2's away to be left with just these numbers, and that's how we use a square root. So now why don't you try to think about one of the laws. We have when a is non-zero, a to the power 0 is equal to 1. How about you think about this? What if a was 0? What would be 0 to the power 0? Would it be equal to 1 or would it be something else? Okay, now that we know what exponents are, let's start on our first problem. So we have to evaluate each of the following. So, A, 3 to the 4th power. 3 times 3 times 3 times 3, which is equal to, we have 3 times 3, which is 9, and then 9 times 3, which is 27, and 27 times 3, which is 81. Let's save B for the last. Let's start on C. 2 to the 6th power. We have 2 times 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 is 64. Okay, now D. Obviously, we don't want to write 1 out 2008 times. So let's do something else. We know how 1 times 1 times 1 times 1, however many times you want to write 1, it would always be 1. So even when you get to the 2008th one, our answer would be 1. Okay, now on to B. So this is -4 to the 3rd power. Right. So we would do -4 times -4 times -4 times -4. So -4 times -4 is positive 16. Positive 16 times -4 is positive 16 times -4 is -64. And then -64 times -4, which would be 64 times 4, 6, and then we have 24, so we have 246. Okay, so I want you to think about something. What, I'm going to give you a challenge problem. Think about it. Are negative 2 to the power 4 and negative 2 to the power 4, I mean like this, -2 to the power 4 and -2 to the power 4 equal? Good challenge and good luck. Okay, now let's do our next one. So for each of the following, replace x with a number that makes the equation true. So A is 2 times 2 times 2 times 2 is equal to 2 to the power x. And that would be 2 to the power 4. And now for this one, we have 3 to the power 2 times 3 to the power 4. Let's use our law. So that would be 3 to the power 2 plus 4 is equal to 3 to the power 6. Now for C, we have 5 to the power 3 times 5 to the power 8 times 5 is equal to 5 to the power x. So we're going to use the law again. We would have 5 to the power 3 plus 8 plus 1, since we could also write this as 5 to the power 1. So we have 5 to the power 12. Now we're going to move on to fractional exponents. Don't worry, it's not let's go on an adventure to fraction land. Okay, now we can do some fractional exponents. In this problem, we evaluate 25 to the power 1 over 2. So, A, what is the value of 25 to the power 1 by 2 to the power 2? So, we have this would be, as you can see, we could turn this into the square root of 25 to the power 2 using our law. So we would have the square root of 25, which is positive or negative 5 plus minus 5 to the power 2, which would take us back to 25. Interesting. Okay, B. What positive number equals 25 to the power 1 by 2? It asks what positive number. Since we have both negative 5 and positive 5, we need to find the positive number, which is 5. Positive 5. Okay, so now we know what fractional exponents are. Why don't you try to find out what the value of 25 to the power 3 by 2 is? Good luck!